Good morning. Today we're going to look at section 6.2. We're going to start working on multiplying and dividing radical expressions. So the first thing, when we are combining radical expressions where they're being multiplied, if the index is the same, so we have the nth root of A, we have the nth root of B, and that they are real numbers, so not imaginary numbers, then we can multiply the A and B back together and take the nth root of the whole product. Right? Now that works both ways. If we start with something like this that's multiplied together, we can break it apart. If it's broken apart, we can put it back together. An important note, the indexes have to be the same in order to combine them. So the first example, notice we have a square root here and we have a cube root over the 5x. So those are not like terms, we can't combine those. However, the next example, they're both cube roots, so we could multiply that back together. Also note, in order to combine radicals, both have to be real numbers. So we cannot have negatives inside even roots because those lead to imaginary answers. Okay? So we can't simply multiply those together. We would have to deal with that negative inside first. So steps for multiplying radical expressions. To combine the expressions, multiply any of the numbers, those coefficients, the front numbers, and any like variables. So we could put x's together, we could put y's together. And then follow the steps for simplifying them that we looked at yesterday. All right, from this section onward, we assume that all variables are positive values. So we do not ask you to deal with the absolute value, that even, odd rule from here on out for the chapter. All right, so notice that we have both of these being square roots, so we can put them together under one big square root symbol. And the reason we would do that is 72 is not perfect, 10 is not perfect. We have some x's here, we have some x's there, same with the y's. So it's easier if it's all back together, and then we can break it up in a better way. So we're going to put this all under one big square root symbol. The 72 and the 10 get multiplied to be 720. Our x's, we have 3 in the first expression and 1 in the second, so we have a total of 4 x's getting multiplied together. And for the y's, we have 2 here and 3 there, so we have a total of 5. And now it's just a matter of simplifying it like we did yesterday. We're going to look for a perfect square in 720. And if you look at your power chart, and 720 is fairly large, so what we can do is divide out some smaller numbers. We could divide by 2, by 3, by 4, by 5, and try to find something that pops out with a factor that is perfect. For example, if we divide this by 5, we get 144 as the other factor. And 144 is perfect. It's on my list of perfect squares. It simplifies down to a 12. So we have a 12 and we have a root 5. Notice I left some space there because we're going to be able to pull some variables out. Looking at our x's, we have 4 of them. We are doing groups of 2 since we're square rooting. So out of those 4 x's, we can make 2 groups of 2 with none left over. For the y's, we have 5 of them. Again, we're doing groups of 2, so we can take out 2 full groups. 2 groups of 2 uses up 4 of those y's. We have 1 left over inside. For the second one, again, we are square rooting both, so we're going to put it together under one big square root. 5 times 35 is 175. Our x's, we have 5 here and 1 there, so we have a total of 6. Our y's, we have 3 and 4, so we have a total of 7. All right, I'm going to let you pause the video for a second and go ahead and try simplifying this one. All right, let's check your answer. 175 we can split up. A perfect square that goes into 175 is 25, and it goes into that 7 times. So for the numerical part, that coefficient in front, the 25 square rooted becomes a 5, and the 7 is still inside since it is not perfect, and it has no other perfect square factors. Our x to the 6th, we are doing groups of 2 again. If we have 6 items, we can make 3 full groups of 2. If we have 7 of these y's, We can again make 3 full groups, but we still have an extra y left over. All right, so if there's numbers outside the radical, we can multiply them separately and keep them outside. So the general rule is multiply the outsides, then multiply the insides, and then simplify. So anything that's out can be put together, anything that's inside can be put together. So for this one, that means we're taking the 5 and the 4 and we're multiplying them and making a 20. They were both outside our cube root symbol, so they're going to stay outside. Inside our cube root, we have 2 times 32, or 64. We have an x squared and another x, so we have a total of 3 x's being multiplied together. And we have a y and a y to the 4th, so we have a total of 5 of those. Okay. Now, the cube root of 64, that one is perfect. It's going to come out as a plain 4. The 20 that's in front is still out front. We have groups of 3, and since we have 3 x's, we can make 1 full group. For the y's, we can make 1 group that uses up 3 of them, but we still would have 2 left over that would have to stay inside that cube root symbol. And then multiplying the 20 and the 4 together, since they're both outside our root symbol, we would get 80 xy times the cube root of y squared. All right, our next one. We have negative 2 times 3. Those are both outside my 4th root. So I'm going to put those together as negative 6. Inside my 4th root, I have 9 times 18, which is 162. Our x's, we have 2 and then 3, so we have a total of 5. And our y's, we have 3 and 5 more. We have a total of 8. So once again, go ahead and pause the video, try this one, and then turn it back on when you're ready. All right, let's check what you did. For 162, we can think of splitting that up into 81 times 2. The 4th root of 81, since that is perfect, it comes out as a plain 3. We still have the negative 6 in front. Inside our 4th root, we still have that 2. And now looking at our variables, if we have 5 x's and we want groups of 4, we can make 1 full group with 1 left over. Our y's, we have 8 of them, which means we can make 2 full groups with no y's left over. So simplifying this, we would get negative 18 xy squared times the 4th root of 2x. All right, one little geometry example. It says to find the area of the rectangle in simplified form. Well, area of a rectangle is just length times width. And they're giving me an expression for length and width, so we are just multiplying these together. So we have 2 times the cube root of 5xy squared. We're multiplying it to the cube root of 5x squared y squared. So that 2 that's in front here is going to stay in front. There's nothing to multiply it to. And then let's combine all the stuff in our cube root. We have a 5 here and a 5 here. That's 25. We have 1x and 2 more, so we have 3 of those. We have 2 y's and 2 y's, so we have a total of 4. Now, the cube root of 25, there's no perfect cube inside 25. Our perfect cubes are 1, 8, and 27. 27 is too big. 8 does not go into 25 evenly. So we can't really break that down. We're still going to have a cube root of 25 in our answer. We still have that 2 out front. For the variable parts, we have 3 x's, and we're trying to make a group of 3, so we can make 1 group. We have 4 y's. We're trying to make a group of 3. We can make 1 group with 1 left over. So our final answer, 2xy times the cube root of 25y. All right, let me know if you have any questions. Otherwise, you can go ahead and get started on the 6.2a worksheet.